So welcome back, and we are now looking at these examples on, let's just see what page it is. We're looking at exercise 11. We're basically practicing now all of our exponent laws put together. So let's take a look at this first one. So remember that when we've got a product, both the things get the power. But remember also that if we already have a power on a number, that 2 squared needs to be cubed, which actually becomes 2 to the 6. Remember, numbers that already have a power, raised to a power, we multiply the powers. The 3 just gets the 3, right? In fact, there's a 1 on that original 3, so the powers are still multiplying. Now we've got 2 to the 4, and we've got 3 squared. Right, now remember, we can't start multiplying these 2's and 3's. Right? They're not normal numbers. What we've got to do is we've got to look at which ones have got the same bases. All right, those two and these two. And then what we've got to do is we've got to multiply those. Remembering that when the bases are the same, we're going to add the exponents. So what we're going to get here, we're going to get 2 to the power of 10 times 3 to the power of 5. And there's our final answer. Okay, this next one, we've got a fraction raised to a power. Now remember, when a fraction gets raised to a power, both the top and the bottom need to get that power. However, if there's already a power on a number, then we will multiply the powers. So we're going to get 2 to the power of 6. And we're going to get 5 to the power of 4. Okay, and there it is. Now, we can't divide those. We haven't got the same base. Okay. If you've forgotten all your laws, it doesn't really matter, because what you can do this question by just multiplying out. What does it mean to square something? It means 2 cubed over 5 squared times 2 cubed over 5 squared. Let's say you don't even remember the rule about multiplying numbers with the same base. What does 2 cubed mean? Well, it means 2 times 2 times 2 times 2. Right? And what does 5 squared mean? Well, it means 5 times 5. All right? That there, all of that there, is just one of these things. Right? Now we've got to multiply. So in other words, that there is that there. Now we've got to multiply in the same thing again. So what we're going to get is we're going to get times 2 times 2 times 2 over 5 times 5. Okay, and what we've got is 1, 2, 3, 4, 5, 6 2's on the top, and 1, 2, 3, 4 5's on the bottom. So these rules make sense. They always make sense. Okay, let's try number C. Remembering that if you haven't tried it yourself yet, pause the video and then try it before looking at how you went. Okay. On the top, we've got a product raised to a power. When we raise a product to a power, both this 2 to the 5 and the 3 must get squared. But remember, when we've already got a power, we multiply the powers. So 2 to the 5 squared is 2 to the 10 times 3 squared. On the bottom, we're going to get 2 to the 6. When you square 2 cubed, you get 2 to the 6. And again, we get a 3 squared. Right, now we've got choices. Okay, singaketa. All right, we can either just divide these out. These are exactly the same number. Right, and they're divided once each. Or we could say 3 to the power of 0. Because when we divide, we're going to subtract our exponents. But what is 3 to the power of 0? It's 1 anyway. All right, what's our final answer going to be? We've got 10 2's on the top, 6 2's on the bottom. If we divide them out one at a time, one from the top, one from the bottom, one from the top, one from the bottom, we're going to get 2 to the power of 4. But remember, we've learned a rule for that. When we divide and our bases are the same, we subtract our exponents. Okay, let's look at this one. This one looks terrifying. It's big, okay? But this is where we need to just keep calm and just remember our rules and do it slowly. Right. So we're just going to start at the top here. This first piece, okay, the 7 to the 4 needs to get cubed. It's going to become 7 to the 12. The 5 also needs to get cubed. There's a normal 2 here. Then there's a 7 squared. Notice I'm writing a times sign here. If I don't write the times sign, we may think that this is 27 squared. Okay, so either put a times sign or leave it in brackets like that. And we've got 5 cubed. Okay, on the bottom, this 7 squared needs to be squared. We're going to get 7 to the power of 4. The 5 needs to be squared. Now, on the top, let's just do it slowly. On the top, let's collect all the terms that have got the same bases. We've got 7s in 2 places. All right? And so the answer to that is going to be 7 to the 14. Right? Remember, we're going to add the powers. We've also got 5 in 2 places. There's 3 5s multiplying together here, and there's another 3 5s multiplying together here. Altogether, we've got 6 5s multiplying together. That's how we write that. And then we've got a times 2 here. On the bottom, we've got 7 to the 4, and we've got 5 squared. Right, now remember, when we divide numbers with the same bases, we are going to subtract the exponents. So we're going to get 7 to the power of 10, we're going to get 5 to the power of 4, and then we've still got our 2. And we just leave our answer exactly like that. Okay. Right, let's look at E. Okay, we've got a fraction raised to a power. Now remember, when a fraction gets raised to a power, both the top and the bottom must get raised to that power. When we've already got a power, we multiply powers. So 3 squared squared is 3 to the 4. 5 cubed squared is 5 to the 6. Exactly the same happens here. 5 to the 4 squared is 5 to the 8. And on the denominator, we've just got a 3, which needs to be squared. So 3 squared. Right, now, when we divide, and the bases are the same, we're going to subtract our exponents. So here we've got a base of 3, and here we've got a base of 3. Here we've got a base of 5, and here we've got a base of 5. When we divide, we're going to subtract the exponents. That's the rule that we've discovered together. So 3 to the 4 over 3 squared will be 3 squared. 5 to the 8 divided by 5 to the 6 will be 5 squared. And there's our answer. Okay, F, 2 plus 2 to the 0. Right, now we haven't got a rule for adding, but this is just 2. What's 2 to the 0? Anything to the 0 is 1. Final answer, 3. Okay, right. Well, we're going to move on now to, and we've looked at this previously when we did prime numbers, right? Remember that we can square root. If we've got exponents, right, we can, for example, if we know that 144 is 2 to the 4 times 3 squared, right, we can work out the square root of 144. And the way we're going to do this, we're going to write 144. Okay, remember, a square root means a number times by itself. So we need 2 identical numbers to give us 244. To give us 144, sorry. Okay, so we're going to build our 2 numbers by putting them into 2 different brackets. But they must be the same number. All right. Now, we're going to need to share out these factors. All right. We've got 4 2's. So let's put a 2 in here and a 2 in here. We've still got 2 more 2's. Let's put another 2 in here and another 2 in here. Do you see that we've used all 4 2's? Right, now, how many 3's have we got? Well, we've got 2 3's, so we can put a 3 in here and a 3 in here. So what we've shown is that 144 is this number, all right, times by itself. You know, 144 is 2 times 2 times 3 times another 2 times 3 times 2 times 3. Right. And so that basically means that 144, when we square root it, will just be one of these numbers. So the square root of 144 will just be one of them, 2 times 2 times 3. And if we work that out, we get 12. And we can check 12 times 12 is 144. All right. Now, what about if we've got a cube root, right? And we are told that 13,824 is 2 to the 9 times 3 cubed. Well, for a cube root, we want a number times by itself and times by itself again. So 3 identical numbers which will multiply together to give us 13,824. So this time, instead of having 2 brackets, we want 3 brackets. We want to say some number times by some number times by some number. But these must all be the same. All right, let's see how we can share this out. How many 2's have we got? There are 9. All right, if we want to share those 9 2's into each of these brackets, how many 2's can I put in each bracket? 9 divided by 3, 3. I can put 3 2's there and 3 2's there. I've used all my 9 2's. All right, remember the 2 cubed means 3 lots of 2 multiplying together. Altogether, we've got 9 lots of 2. Into each bracket, I've got 3 3's. Into each bracket, I can just put 1 3. Okay, there we have it. Now, our final answer here for the cube root of 13,824, I just need to take one of these brackets. All right, so I'm just going to take 2 cubed times 3. And 2 cubed times 3 is 8. 2 times 2 times 2 is 8 times 3 is 24. Let's check that with a calculator. Okay, so we're going to use the cube root button. There it is over there. Shift cube root 13,824. And there it is. 24 is the answer. Okay, right. We're going to ask you to pause the video now, and we're going to ask you to try the questions on page 33, and then we're going to ask you to let the video play again to see how you went. Okay, so now we're trying to find the square root of 2 to the 6 times 3 squared. Right? Well, that number will just be half of each of the numbers of 2's and each of the numbers of 3's. All right? This will be 2 to the 3 times 3. Because if we were to multiply this by itself, we would get back to what's inside there. Right? The number here is actually just 24 as an answer, but we can just go with that. Right? Let's think about this one. We now want to take this stuff inside here and we want to make it into 3 identical groups, but the cube root will just be one of those groups. So what if we were to divide these 2's into 3 groups? We would have 1 2 and we would have 3 3's. Okay, right. What we can, there's our answer, but let's just check. If we were to multiply this by itself and by itself again, in fact, I'm not even going to do it like that. I'm going to say if we were to cube that, right, then we would get back to 2 to the 3. Remember our exponent laws that we've just been working on? Both the 2 and the 3 cubed must get cubed, and we get 3 to the 9. Now this here is exactly what we were trying to find the cube root of. Okay, so this here is exactly that there, which means that 2 times 3 cubed must be the answer. Right, cube rooting and cubing are undoing of one another. Right, so now we've got some questions to do here. We are given the prime factorization of this very big number. It's 4.4 million, 4,410,000, right? And we asked to find the square root. Now the square root means that we must take exactly half of the factors. Because remember, we could write 4,410,000. We could write it into 2 identical brackets. Okay, how many 2's could we put in each bracket? That's right, we could put 2 in each because we've got a total of 4. How many 3s? Ellie Lordwood, just 1. How many 5s? We could put 2 5s in each. And how many 7s? Ellie Lordwood, just 1. Right, so this number over here is 4,4 million. All right, 4,410,000, this stuff in orange. Now, the square root will just be a number that will multiply by itself to give us 4,410,000. So our square root is just going to be one of these brackets. 2 squared times 3 times 5 squared times 7. Right, and we're told that we can leave our answer exactly like that. Okay, right. The next one, we want a cube root. So the cube root means that we would divide this into 3 brackets this time. Right, so this time we'll go for 3 brackets. Right, how many 2's can I put in each bracket? If I've got 6, I can put 2 2's in each bracket. How many 3's can I put in each bracket? 3 3's in each bracket. And how many 11's can I put in each bracket? Just 1. Okay, so what we hope you understand is that enormous number, all right? And we've written it, sorry, I didn't write the 3 cubed in this bracket. We've written it as 3 identical numbers multiplied together. So the cube root is just going to be one of those. 2 squared times 3 cubed times 11. Okay, all right. So now we've got some more practice, and we're going to ask you to try this before the next time. But before we do, just let's have a look at some examples at the bottom of the page here, at the bottom of page 33. If we asked you to find the square root of 2 to the 16. Okay, now remember what we're wanting here. We are wanting a number that's going to multiply by itself to give us 2 to the 16. Right, so it's going to be 2 to the something. All right, now remember, when we multiply, we are going to add our exponents. So in fact, to find a square root, we must actually halve this exponent, because when we multiply 2 to the 8 by 2 to the 8, right, that exponent's going to double. So when we find a square root of a number, we actually halve the exponent. When we find, let's have a look at another one. When we find the cube root of a number, let's say we have 5 to the 9. Right? Now, what number can I multiply by itself and by itself again to give me 5 to the 9? Okay, right. And the answer is 5 to the 3. If you multiply 5 to the 3 by 5 to the 3 by 5 to the 3, you get 5 to the 9. So the cube root of 5 to the 9 would be one of these numbers. Right, in other words, it would just be 5 to the 3. Okay, and what you'll see is that we've actually taken that power and we've divided it by 3 when we find a cube root. We've divided it by 2. We've taken the power and divided it by 2 when we find a square root. Okay, before the next lesson, we're going to ask you to try the questions on page 34 and 35. Right, and then we're going to go into the next piece of this section. Okay, have a great day, everyone.